Welcome to magnetism and electricity, Maxwell's work, the connection. First, let's look at magnetism. Two bar magnets here, or two U-shaped magnets. Here you see two straight bar magnets. Here's a compass. What affects a compass? Does electricity affect a compass? No, only a magnetic field given off by iron affects a compass. It has nothing to do with electricity. The magnetic field is also an invisible force field capable of moving objects. Why is this nail moving? The magnet is not touching the nail. It's called the magnetic force. It's an invisible force field. And you can pick stuff up with it. Okay? Magnetism. Magnetism is so strong that if we take two refrigerator magnets of opposite polarity and I ask you to stick them together, you can't do it no matter how strong you are, because the magnetic force is stronger than any human being. Okay? And the only thing that affects the magnet is, or the compass is, a magnet. And then we have our friend electricity. All right? What makes electricity? Yes, a wire and a bulb and a socket, yeah, some power plant, okay? But we certainly can't make electricity by that, or I can't put it in my hands. We need some kind of generator, right, in order to produce electricity. Well, in the early 1800s with James Clerk Maxwell, he did some other experiments with magnetism and electricity, and this is one of them. He was very intrigued by this fact that there's a magnetic force that can move things. And he reasoned, if a magnetic force can move things, then if I generate an electric field, which this is just an electrical wire with a switch in it, Maxwell figured that he could make an electric field make a magnetic field move. And watch what happens to the compass needle. It's moving, but nothing is touching it. I'm merely passing electricity through a switch, all right, making the magnet spin. This shows a relationship between electricity and magnetism. So what's that all about? Well, I have a demonstration that a colleague of mine and I built many years ago, okay, which shows Maxwell's understanding of electricity and magnetism, which is today the basis of our entire modern world. So what you see before you is some bar magnets that are, or some U-shaped magnets that are stood up on end, and I have a bar magnet going down the center of it with a crank handle. All right? This is not a joke. There's no wires. It's not connected to anything. And notice that I have a light bulb, a regular light bulb that we just saw lit, connected to a socket that connects to nothing but the magnets. Now watch this. As I make the magnetic field move through the magnetic field, it produces an electric current. Here I'm creating electricity from magnetism. And not only that, the electricity that is being generated is technically an electromagnetic wave, okay, of vibrating electric and magnetic charges that is glowing at 550 nanometer. And if I just pull this one tiny wire, copper wire, what flows down the copper wire to make electricity? Electrons, that's right, okay? And without it connected, I can spin all day, I get nothing, okay? I connect it to the end, I spin, okay? This shows that the magnetic field is producing a flow of electrons that move down the wire and create electricity. The electricity then generates an electromagnetic wave vibration of about 550 nanometers, and we get what's called electromagnetic induction. So what, Professor Geiger or whatever you are? So what? You get this, a motor, the full reason of the 21st century. Notice, iron, copper, This makes a motor, this makes it spin, this makes our modern world. Electromagnetic induction, James Clerk Maxwell. Y'all have iPhones and pads and things. You ever notice that big heavy thing on the end of the wire there? Well, if you cut one open, you'll discover that it's a big piece of iron surrounded with hundreds of pieces of copper coil. Electromagnetic induction. Maxwell's understanding that magnetism generates electricity and electricity generates magnetism, and from that we can make circuits that then make motors, which is our whole 21st century world. Thank you very much.